All right, so today we're going to talk about section 2.2, conditional statements. Ooh. Okay, so a conditional statement is an if-then statement, like if you eat your dinner, then you can have dessert. That's an example as an if-then statement. Okay, so the first part, the part following the if, is called the hypothesis. And you'll need to have this memorized. So then the conclusion is the part following the then. So if you see it with symbols, it looks like this. If P, then Q. Or you could also read it as P implies Q. All right, so what are the hypothesis and the conclusion of the conditional? So if an animal is a robin, then the animal is a bird. So the hypothesis is the part following the if. So this would be the hypothesis. And then the part following then would be the conclusion. Not too bad, right? Next one, same thing. What are the hypothesis and the conclusion of the conditional? So if an angle measures 130, then the angle is obtuse. So this would be the hypothesis. And then this would be the conclusion. Okay, how can you write the following statement as a conditional? So we need to throw an if and a then in there and break it up into two pieces. So vertical angles share a vertex. Well, this looks like the first part, the hypothesis, and they use the variable p, remember? And then shares a vertex looks like the q, or the conclusion. So let's say if two angles are vertical, then they share a vertex. All right, the next one. How can you write dolphins are mammals? So let's say this would be the P, and then this would be the Q. So if an animal is a dolphin, then it's a mammal. All right, let's move on. So truth value. So truth value of a conditional is either true or false. So to show that a conditional is true, show that every time the hypothesis is true and the conclusion is also true. And that has to happen every time. So to show that a condition is false, find only one counterexample. So if you can find one counterexample, then it's false. There's no sometimes in this, for which the hypothesis is true and the conclusion is false. Okay, is the conditional true or false? If false, find a counterexample. If a woman is Hungarian, then she is European. That is true. Okay, so we don't have to find a counterexample. If a number is divisible by 3, then it is odd. Well, that's false. 6 would be a counterexample. 12. There's a bunch of them. Okay, is the conditional true or false? If it is false, find a counterexample. If a month has 28 days, then it is February. I would say false. All months have 28 days. False. All months have 28 days. I didn't say if a month has only 28 days. Okay, if two angles form a linear pair, then they are supplementary. Well, that's true. That's the definition of a linear pair. Okay, so let's go to the next page and let's talk about negations. So a negation of a statement is the opposite of the statement. And you write it with a little squiggle and then whatever the letter is. And it's read as not P. So the negation of the statement is the sky is blue is the sky is not blue. You can use negations to write statements related to a conditional. Every conditional has 3 related conditional statements. Okay, this whole little chart right here is something that I would screenshot so you can reference it when you're doing your homework and you can study it. So a conditional is just what we've talked about. It's the if then. So if P, and I'm going to be looking at the second to last column, the symbols column, because that kind of helps me. So if P, then Q. Okay. The converse of it would be you switch the hypothesis and the conclusion. So if Q, then P. So the last part comes first. You just switch them. Okay, the inverse is if not P, then not Q. So you do the negation of both P and Q, and it comes in order of not P, then not Q. The contrapositive would be you switch them, like you did on the converse, and you do the negation. So if not Q, then not P. I know this stuff is a little weird. It'll start making sense once you do it more, but definitely save this chart and it will help you. Okay, so here are some truth values of the related statement above. Equivalent statements have the same truth value. So a conditional, if the measure of angle A is 15, then angle A is acute. Well, that's true. Okay, the converse, so switch them. If the angle A is acute, then the measure of angle A is 15. Well, that's not always true. You can have an acute angle that's not 15, so that would be false. The inverse, remember that's not P, then not Q. So if the measure of angle A is not 15, then it is not acute. Well, that's not true. You can have like we just said, you can have other acute angles that are not 15. So contrapositive, so you flipped them and you did the negation. So if angle A is not acute, then the measure of angle A is not 15. Okay, true. If it's not going to be acute, there's no way it's going to be 15. So that would be true. All right, so a conditional is and its contrapositive are equal statements. They are either both true or both false, and the converse of a statement are also equivalent statements. Okay, so that last part, what are the converse, inverse, and contrapositive of the following conditionals? So I'm going to go ahead and start typing on this. I think it'll be easier. So the statement was, if the figure is the square, then it is a quadrilateral. Okay, so let's just label them first. So go back. If the figure is a square, so the figure is the square is your P, then the figure is a quadrilateral. That's your Q. And the first one, we have to find the converse, inverse, and contrapositive of the conditional. And what are the truth values of each? And if the statement is false, give a counterexample. So go back. Let's see. Converse is when you switch the Q, then P. So if Q, then P. We need to switch them. So we're going to switch the Q and P. So it would be if the figure is a quadrilateral, comma, then it's a square. Okay, let's label that. So that would be, we said that is the converse. Okay, the inverse is going to be, let's go back to our chart. Let's look at it. Inverse, maybe. Oops. The inverse is when you switch, or no, I'm sorry, you don't switch them, and you use the negation. So if not P, then not Q. So if not P, then not Q. Sorry, this is kind of crazy. Oh my gosh. Okay. All right, sorry. So if not P, then not Q. Okay, so, oops. So if not P, then not Q. So if the figure is not a square, comma, then it's, I need an apostrophe, it is not a quadrilateral. Okay, so that's the inverse. The last one was the contrapositive. So the contrapositive is, let's recap, is when it's, so you flip them, so it's not Q, then not P. So flip them and use the negation. So the contrapositive would be if the figure is not a quadrilateral, comma, then it's not a square. Okay. So we have the converse, inverse, and contrapositive. And so now we need to find the truth values of each. And if it's false, we need to give a counterexample. So if the figure is a quadrilateral, then it's a square. Well, that's false. It could be a rectangle. It could be a parallelogram. Let's just say that one. Parallelogram is an example of a quadrilateral that is not a square. Okay, if the figure is not a square, then it's not a quadrilateral. So if it's not a square, it can't be a quadrilateral. False. Again, you can have other figures that is not a square and not a quadrilateral. Like a parallelogram, again. Okay, if the figure is not a quadrilateral, then it's not a square. Well, that's true, because if it's not a quadrilateral, there's no way it's going to be a square. And that is all we have for this lovely 2.2 section. Hope you enjoyed it. Oops, what did I do?